Okay, so we've got a Venn diagram here. Remember, the numbers that you're given here are the number of elements. We don't know what those things are, but it tells you how many elements, how many items there are in each region of the diagram. First of all, the universal set contains 37. I can't put that on the diagram, but I'll just make a quick note of it here to tell me that within the diagram there must be 37 elements altogether. The number of elements in set A is 22. I still can't do that because there are 22 altogether, but I don't know how those 22 are distributed between the two areas. Some of them might be only in A, some of them might be in the intersection of A and B. So I can't really put that on yet. I might just write 22 here just to remind me. What it does then tell me, though, is that in the intersection of A and B, and that's where the two sets overlap, there are 12. So the number of items in the intersection of A and B is 12. So I can write 12 there. I now can start filling things in because I know that altogether in A there must be 22 items. It means that there must be 10 in that section. Okay, let's carry on. I can't do anything else yet. I've used that. I've still got two regions to fill in. Let's have a look at what this means. N of A union B. So in the union of A and B, now the union means all of this. So everywhere where A and B, anything that's in A or B or both, there must be 30 items. Now altogether here I've got 22, which means I must have 8 here. So that altogether I've got 12 plus 8, well that's 20. I've got 30 items or 30 elements altogether in A and B. Now if that's 30 and the universal set contains this 37, there must be 7 out here. Okay, so let's have a look at what they're asking us. A intersection B dashed. Now that means the area of the Venn diagram which is in A but not in B. So which part of the Venn diagram contains the elements which are yes in A but not in B? Well, that must be these ones here. They're in A, but they're not in B. In other words, N of A intersection B dash, and already these are numbers, so we don't need to worry about counting anything. A intersection B dash is going to be these 10 here. Now, this I think is very difficult, but there's a very useful identity which you should know, and that is the not N even, A dash union B dashed is the same as A intersection B with a dash, or the complement of. And in the same way, not really relevant now, but A dashed intersection B dash is the same as A union B dash. Now these ones on the right are far easier to find, I think, than these ones. So I'm going to use the identity here. This is the same as the number of elements of A intersection B dash. Now that's quite easy. A intersection B is the 12 in the middle. A intersection B dash, though, the complement of A intersection B is everything except those 12 in the middle. In other words, it's the remaining numbers 7 and 10 and 8. Well, 8 and 7 is 15, plus the 10 is 25. Or you could have just done 37, take away the 12. Either way, the answer there is 25.